We graph rational functions. First thing you want to do is check to see if the top factored, because if it does, there might be a removable discontinuity. So let's factor the numerator. That'd be x plus 3, x plus 1, all over x plus 2. So it's the same function, just factored now. You can see that nothing cancels out, nothing reduces, so there's not a removable discontinuity. Instead, there's just a vertical asymptote. And the denominator equals 0, which is x equals -2. So draw that vertical asymptote at x equals -2. Then we can look for a horizontal asymptote, which we look at the coefficients of the largest degree in the entire problem. So the largest degree is x squared. In the numerator, we have 1x squared. In the denominator, there's not an x squared, so it's 0x squared. So that's 1 over 0, which is undefined because there's no horizontal asymptote. Instead, there's a slant or oblique asymptote. To get the equation for the slant or oblique asymptote, you have to do division. We're dividing x squared plus 4x plus 3 divided by x plus 2. Since we're dividing by x plus 2, we can do synthetic division because that's a linear divisor. So we can do synthetic division with a -2 into 1, 4, 3. So synthetic division, we get 1 times -2 is -2. Add, we get 2. Multiply, we get -4. Add, we get -1. This is the remainder, which has nothing to do with our slant asymptote. Our slant asymptote is just from the 1, 2, which is 1x plus 2. So our slant asymptote equation is y equals 1x plus 2, or x plus 2. So we can graph that. That's just a line. It's our asymptote. It starts at 2 on the y-axis. That's our y-intercept. It goes up 1 over 1. So all those points, I'm going to get my straight edge. There's the asymptote. So now we have our vertical and slant asymptotes drawn in. We can figure out our x and y intercepts. So to get our x intercepts, you plug 0 in for y, which means you set it equal to 0. And when you set it equal to 0, the only thing that would make this equal 0 is if the numerator were 0. So we have two x-intercepts at -3 and -1. -3 and -1. So basically you're setting the numerator equal to 0 for your x-intercepts. You get x equals -3, x equals -1. 2 dots. 2 points. So your x-intercepts are -3, 0 and -1, 0. Your y-intercept, you plug in 0 for x. So plug in 0 for x. I'll go back to the original function, not the factored one. 0 plus 0 plus 3 is 3. Over 0 plus 2 is 2. So our y-intercept is 3 over 2. As a point, 0, 3 over 2. And we can sketch that in. 3 over 2 is 1.5, so that's right there, getting pretty close to the asymptote. If you needed more points, you could plug in any values for x that you want. You can plug in 1, 2, 3. You can plug in -4, -5, -6. You plug in 10 and negative, whatever you want to plug in. But this is enough to actually know where the graph is, because it has to pass through these 2 points and go with the asymptote. Go with the asymptote through those points and with the asymptote through that point. So there's our graph.